We try to prove this inequality here. This is going to be sum from 1 over 2, 1 over 5, 1 over 10, up to 1 over 2023 square plus 1. Notice that this is just 1 square plus 1, 2 square plus 1. That's 10 is 3 square plus 1, right? Now, for this problem, I'm going to take a different approach. ChatGPT with interpreter can actually analyze and solve math problems. So I'm having a conversation with ChatGPT. Notice that initially it's kind of went to the wrong direction, and later said, observe that this function here, 1 over x squared plus 1, is strictly decreasing. So we're going to use Riemann sum and integral to solve this problem. Decreasing function in this interval. So the right Riemann sum would underestimate the integral. All right. So here, specifically for each subinterval here, k range from 1 to 2023, rectangle with value at k, right? And since from k minus 1 over k, the integral would be bigger. So the whole thing here as the sum, the left-hand side of this inequality is the quantity that we're interested in, and it's going to be less than this integral here. Of course, 1 over x squared plus 1, the integral is going to be arctangent, right? So here, the sum is indeed less than pi over 2, because arctangent, the max value is going to be pi over 2, right? This number is very big. And then as getting bigger is approach to pi over 2, right? So here, that's the solution by the ChatGPT, after some guidance, right? So of course, let's look at why that is the case, right? So we're going to resort to decimals for the graph. This curve is strictly decreasing, from here 0, 1 to, of course, we didn't show the endpoint, which is 2023, but here the green shaded rectangle representing if we have the step size of 1, right? And then we use right Riemann sum, that is from this 0 to 1, we take the value of 1 here, which in this case would be 1/2 of the y value. So this rectangle is going to be less than the area under the curve, right, for this segment. Since function is strictly decreasing, so at each step, the Riemann sum, which is represented by the green shaded rectangle, is going to be strictly less than the true integral value. So back to our problem. So whenever you see a summation like this for certain inequality problem, you want to use this method. That is, try to turn the summation into a Riemann sum of certain integral of a function. So in this case, of course, the function is 1 over x squared plus 1, right? Notice that we have a series on the math problems with number 2023. Okay, so we started at the beginning of the year, like for example, for a simple question, is 2023 a prime number, to some inequality proofs. So do check out the playlist. Now in particular, I like this one. We try to find the sum of the first 2023 harmonic series.